You click on Google, instant. You open Amazon, instant. Then you visit a random blog and you're staring at a spinning wheel for 5 seconds. Same internet, same device. So what's the difference? It's not just better servers, it's something called a CDN, plus caching, plus a lot of invisible engineering most people never think about. Let's break down what's actually happening every time you open a website. The real problem: distance. Every website lives on a server somewhere in the world. When you visit a site, your browser sends a request to that server. The server sends back HTML, images, CSS, JavaScript, videos, everything needed to build the page. Here's the problem. That server might be thousands of miles away. If you're in New York and the server's in California, your data has to travel across the country and back before anything shows up on your screen. Even though data moves through fiber at about 2/3 the speed of light, distance still creates latency. That delay is called latency. And here's what most people don't realize. A round trip across the US can easily take 70 to 100 milliseconds just for travel time. Add server processing, add multiple file requests, add network congestion. Now you're at 1 to 3 seconds, and users start noticing delays at 100 milliseconds. At 3 seconds, almost half of them leave. Distance is the first enemy of speed. The solution: CDNs. CDN stands for Content Delivery Network. Instead of hosting a website on one server in one location, a CDN copies your website's content onto hundreds of servers around the world. These servers are called edge servers or points of presence. So instead of you in London, server in California, it becomes you in London, server in London. That one change cuts latency massively. How a CDN actually works. Let's say you open Netflix. Netflix works with CDN providers like Cloudflare, Akamai, or Amazon Web Services. Here's what happens. 1. The CDN stores copies of Netflix's files on servers worldwide. 2. You hit play. The CDN automatically routes your request to the closest edge server. That server checks if it already has the file stored. If it does, that's called a cache hit. You get the file almost instantly. If it doesn't, that's a cache miss. It fetches the file from the original server, stores a copy, and sends it to you. The next person nearby gets it instantly. That's why big sites feel instant. They're not loading from one location. They're loading from everywhere. Caching is the real secret weapon. CDNs are powerful, but caching is what really makes the internet feel fast. Caching just means storing copies of data so you don't have to regenerate or re-download it every time. There are 3 major layers. 1. Browser caching. Your browser saves files locally: images, CSS, JavaScript, fonts. When you revisit a site, your browser doesn't ask the server for everything again. It uses what's already stored on your device. Servers control this using HTTP headers like cache control, max age 86400, or cache control no store. That's why a site loads much faster the second time you visit. 2. Server-side caching. Some websites generate pages dynamically. For example, a blog running on WordPress builds a page using database queries every time someone visits. Without caching, that can take 1 or 2 seconds. With server-side caching, the fully built page is stored in memory using tools like Redis. The next visitor gets the ready-made version in milliseconds. Huge difference. 3. CDN caching. This is where scale happens. Static files like images, videos, CSS, JavaScript, and fonts get stored on edge servers globally. One file can be served to millions of people without touching the original server again. That reduces load, prevents crashes, and keeps things fast during traffic spikes. Without CDNs, viral content would break the internet. What can and cannot be cached? Static content is easy. It rarely changes. Dynamic content is trickier. Things like blog posts, product pages, public API responses can often be cached temporarily, but personalized data cannot be shared. Your shopping cart, your email inbox, your dashboard. That content is private, so it either bypasses CDN caching or uses special rules. Modern CDNs can even cache dynamic content intelligently using techniques like edge computing and smart cache keys. That's where things get advanced. The hardest problem? Cache invalidation. There's an old joke in computer science. There are only two hard things: naming things and cache invalidation. Here's why. If you update your website, people might still see the old cached version. So developers use expiration timers, manual cache purging, or versioned file names like style.v2.css. Some providers can invalidate cache globally in under 200 milliseconds. That's serious infrastructure. Real companies that make the internet fast. Almost all major websites use CDNs. Netflix runs its own CDN called OpenConnect. Their servers are often inside your internet provider's network. Google and YouTube operate massive global edge networks. Amazon uses CloudFront via AWS. Over 20% of the internet runs behind Cloudflare. Without CDNs, large-scale streaming, software updates, and viral traffic wouldn't work. The origin servers would collapse. Other tricks that make sites feel instant. CDNs are just one piece. Here's what else matters. Compression. Files are compressed using gzip or Brotli before being sent. A 1 megabyte file might shrink to 300 kilobytes. Image optimization. Modern formats like WebP reduce size by 25 to 35% compared to JPEG at similar quality. Minification. Removing white space and comments from CSS and JavaScript reduces size without changing functionality. HTTP2 and HTTP3. These protocols allow multiple files to be downloaded simultaneously over one connection instead of one at a time. Lazy loading. Images below the visible part of the page load only when you scroll. All of this adds up. Speed is rarely one thing. It's 20 small optimizations working together. So why are some websites still slow? Usually one of these: no CDN, bad caching rules, huge uncompressed images, too many ads and tracking scripts, cheap shared hosting, poorly written JavaScript, or too many third-party API calls. Speed is engineering, and not every site invests in it. The good news is, even small websites can use services like Cloudflare for free and dramatically improve performance. The bigger picture. When a website loads instantly, it feels simple, but behind that click is global infrastructure, edge servers, caching layers, compression, smart routing algorithms, billions of dollars and decades of engineering so that you never notice the delay. The internet feels fast because the heavy work is happening close to you, not across the planet. Next time a site loads instantly, you'll know why. And next time one doesn't, you'll know exactly what they didn't do. Have you ever noticed a website loading unusually fast or slow? Drop your experiences in the comments. And if this breakdown of internet infrastructure fascinated you, hit that like button and subscribe for more deep dives into the technology that powers our digital world.